Climate change.
It's December 13, 2022, Wednesday. Good morning, Philippines. For the Globe's latest news, I'm Paul Aguilar.
And I am Jessica Maygalang. Together, we are here to deliver
The most trusted and unbiased news, only here on Balitang News. Our top stories for today. History of atmospheric chemistry finally unraveled.
volcanoes being accountable for atmospheric oxidation. Scientists found out.
Local residents in the Philippine area has felt the impact of atmospheric chemistry.
History of atmospheric chemistry finally unraveled. For the further details, here's Mr. Cruz.
Thanks for that. Did you know our atmosphere went into changes? Earth's original atmosphere, or also known as the early atmosphere, was probably just hydrogen and helium, because these were the main gases in the dusty, gassy disk around the sun from which the planets form. The Earth and its atmosphere were very hot. Molecules of hydrogen and helium move really fast, especially when warm. Actually, they move so fast they eventually all escape Earth gravities and drifted off into space. In addition to that, Earth's second atmosphere, which is called the reduction stage, came from Earth itself. There were a lot of volcanoes, many more than today, because Earth crust was still forming. Back to you, Ms. Galang.
Thank you, Mr. Cruz.
Volcanoes being accountable for atmospheric oxidation, scientists found out. Here's Mr. Danan for further details.
Thank you for that. The volcanoes release steam H2O with 2 hydrogen atoms and 1 oxygen atom, carbon dioxide with 1 carbon atoms and 2 oxygen atoms, ammonia with 1 nitrogen atom and 3 hydrogen atoms. The third stage of our atmosphere is the present atmosphere we have today, which is also known as the oxidation stage. Much of the carbon dioxide dissolved into the ocean. Eventually, a simple form of the bacteria developed that could live on energy from the sun, carbon dioxide, in the water, producing oxygen as the waste product. Thus, oxygen began to build up in the atmosphere, while the carbon dioxide levels continued to drop. Meanwhile, the ammonia molecules in the atmosphere were broken apart by sunlight, leaving nitrogen and nitrogen. Nitrogen, being the lightest element, rose to the top of the atmosphere, and much of it eventually drifted off into the space. Jean-Paul Dano reporting. Back to you, Mr. Paul.
Thank you, Mr. Danan.
Local resident in the Philippine area has felt the impact of atmospheric chemistry. For additional details, here's Ms. Guevara.
As a result of controlling the concentration and distribution of key climate-changing substances like water vapor, methane, or tropospheric and stratospheric ozone, atmospheric chemistry has recently been discovered to play a significant role in climate change. The relationship between chemistry and climate, however, is a two-way street, and modifications in the climate can have a variety of effects on the atmospheric chemistry. Actually, Ms. Jess, there is plenty of data showing an increase in surface emission and concentrations of globally significant trace gases. The atmospheric abundance of major greenhouse gases that deplete stratospheric ozone continues to increase. However, the observed annual increase in CH4 has declined during the last 2 decades. This increase is highly variable. It was near zero in 1992 and as large as positive 13 ppb during the year 2000. Changes in atmospheric composition and chemistry over the past century have affected and those projected into the future will affect the lifetimes of many greenhouse gases and thus alter the climate, forcing an anthropogenic emissions. The development of feedbacks between atmospheric chemistry, climate, and the biosphere did not allow for their inclusion in the estimated number in this case. A systematic inaccuracy is likely to result from leaving out this link, which might significantly change the expected increases in the main greenhouse gases. I think that's all. Back to you, Miss Galang.
Thank you, Ms. Guevara.
And Balitang News will be right back.
Sir? Sir! We are rolling!
Oh, hello everyone, good morning. So, today, I'm going to share to you some facts about atmosphere. Did you know, at an altitude of 100 kilometers above sea level, a border represents the separation between the atmosphere and the outer space. This border is known as the Kármán line. In the 90s, Hungarian physicist Theodor von Kármán determined the boundary to be around 50 miles up or roughly 80 kilometers above sea level. However, the distance of 100 kilometers from the Earth's surface is what is considered generally as an imaginary boundary. In fact, it is not easy to distinguish between space and not space because of the fact that the Earth's atmosphere doesn't simply vanish. Rather, it gradually becomes thinner and thinner over about 600 miles. And if atmosphere becomes more thinner or rather disappear like bubble that pops, do you know what will happen to us? We will die with so much pain. But of course, there's still many ways to survive it. So there's nothing to worry about, and that's all. See ya!
Welcome back to Who Wants to Be a Millionaire? For 200,000 question, are you ready, Mr. Jesus?
Yes, I'm ready.
So here is your question. Arrange the parts of atmosphere in order from nearest to farthest. A. Troposphere, hydrosphere, exosphere, atmosphere, thermosphere. Letter B. Troposphere, stratosphere, mesosphere, thermosphere, exosphere. Letter C. Thermosphere, stratosphere, mesosphere, exosphere, troposphere. And letter D. Exosphere, stratosphere, hydrosphere, atmosphere, and geosphere.
I think my answer will be letter B. The troposphere, stratosphere, mesosphere, thermosphere, and exosphere.
Your answer is correct. So, troposphere is located 0 to 16 km above the surface, while stratosphere is located 16 to 50 kilometers above the surface. Mesosphere is located 50 to 80 kilometers, and thermosphere is located 80 to 640 kilometers. Lastly is the exosphere, and it's located 640 to 64,000 kilometers above the surface. So for 500,000, are you ready, Mr. Jesus?
Yes, I'm always ready.
So here is the question. Which of the said parts of the atmosphere is responsible for burning the meteors falling through the Earth? A. Troposphere, B. Atmosphere, C. Mesosphere, D. Exosphere.
I think my answer will be letter C, mesosphere.
Your answer is correct. Mr. Gregorio, kindly explain the different functions of different parts of the atmosphere.
Thank you, Mr. Ikban. Atmosphere has different layers. Each layer has their own functions and uses that is helpful to us humans and help us. Troposphere is the lowest layer of the atmosphere. It holds the air that we breathe and the air that plants uses to breathe. The higher you go to the troposphere, the cooler it is. This is because almost of the heat from the troposphere are coming from the humans in the surface of the earth. Weather also happens here, including the formation of different clouds. Stratosphere is the home of the ozone layer. UV radiation from the sun turns bind the oxygen molecules in the air, forming the ozone. This layer also absorbs the UV radiation from the sun, providing us cover from the harmful rays. The more you go up in the stratosphere, the hotter it is. It is also weather-free, which is the best place where aeroplanes and jets fly in. Mesosphere is the middle layer of the atmosphere. In this layer, most of the meteors falling from space burn up here. This is the coldest place in the Earth system. Thermosphere is the home of the aurora borealis, one of the thickest layers of the atmosphere, and the International Space Station orbits here. There's this layer called the ionosphere. Ionosphere is the responsible for boundary between the lower atmosphere and the higher atmosphere, located at the lower area of the thermosphere. Exosphere is the highest part of the atmosphere, and it is basically the introduction of outer space. The Earth's satellites orbits here. Thank you.
Thank you for that, Mr. Gregorio. And now, bago tayo mag-proceed, tanungin ko muna kung anong nararamdaman mo ngayon.
Siyempre, medyo kinakabahan kasi ito na yung last question and it will be worth 1 minute. Pero, since ito na yung last question, I'll do my best to answer the question and I think kayang-kaya naman yun.
Okay, good luck. So, here is your question for 1 million. Which of this is not a function of the atmosphere? A. Atmosphere doesn't have an important role in the water cycle. B. The atmosphere shields the Earth from UV radiation. C. Keep our planet warm. And D. Supply oxygen, H2O, and carbon dioxide to living organisms.
Parang mahirap na last question, pero since may last life naman ako, I think I'll use the last line I have, a call a friend one.
Sure! Sino gusto mong tawagan?
I want to call the dear friend of mine from college, Miss Joy Isabel Conan.
Okay, technical. Please call Miss Joy Isabel Pereira.
Hello, Miss Joy.
Hello.
Can I ask you a question?
Sure. What is it?
Can you please explain to us the general function of the atmosphere?
Sure. Atmosphere is our protector. It basically shields us from the harmful ultraviolet rays from the sunlight. This is achievable by the formation of the ozone layer. Atmosphere is also act as a blanket that prevent various gases from escaping from the earth, such as oxygen, nitrogen, carbon dioxide, and the other trace gases, which is helpful to us living organisms to continue the reproduction of the needed gases. Because of the insulation it provides, it maintains the temperature of the earth with no sharp changes, thus makes radio communication possible. And lastly, this is the reason for the weather formation, which is also a crucial need for survivability. And that's all. Thank you.
Thank you, Miss Joy. I think my answer will be letter A.
And the 1 million pesos correct answer is sa pagbabalik ng Who Wants to Be a Millionaire?
Niluto ko na lahat yan, ate, at your favorite!
Thank you very much. You know that I love chicken crackers.
Chicken crackers. Mama, it's my favorite.
Welcome back to Who Wants to Be a Millionaire? And the answer for 1 million peso question is letter A. Congratulations. Yeah. Thank you for watching.
Did you know that the air we breathe today underwent different phases before it became the air now? Hi, I am Liv Dongallo, and I am your host in BSEE Science, exploring the secrets of the universe, featuring the Earth's atmosphere, brought to you by the BSEE channel.
About 13.7 billion years ago, we are in a single hot dense point. A point where it all began. A point that started everything we see today. The solar system. Yes, it doesn't look like ours today. Very different indeed. It was just full of dust, full of space debris. And Earth is one of those dust. The dust that accumulated dust, that accumulated dust, that accumulated dust. It was back in 4.6 billion years ago. Our beloved planet was born. Not that Earth. This is the newborn Earth. The atmosphere here is not habitable. It's so hot. The atmosphere here is not what we have today. It's very hostile. The atmosphere here is full of volcanic eruptions. So intense. Volcanic eruptions spew out gases. Carbon dioxide, water vapor, nitrogen, methane, and ammonia. Is there an oxygen? No. Is there any living organism? No. The Earth is not ideal to me. It's not for me. It is not where I used to live. It's simply not habitable. Welcome to reduction stage. Remember what I said? Water vapor. As the earth cools down, these water vapor gradually condenses. Slowly and slowly, the condensed water accumulate, forming an ocean. Oceans before were lifeless, very plain and creepy. We have water, The clouds were blue. The earth is now blue. We have water. It gradually builds up the seabed. We have water. But where is life? Earth is in the habitable zone, also known as the Goldilocks zone. In this zone, water is liquid. The temperature is just right for lives to form. What life? Not long enough, cyanobacteria were formed. The first life on Earth was born. About 2.7 billion years ago, the cyanobacteria evolves into different complex life forms. The evolution of cyanobacteria gives birth to algae, and the third stage of the atmosphere begins. The oxidation stage. Plants began to grow. Carbon dioxide and water were used by the plants to produce oxygen. With oxygen, animals started to evolve alongside humans, which in return produces carbon dioxide. And the gas respiration cycle starts. In the fact, this is the atmosphere we have now. 78% nitrogen, 21% oxygen, and 1% trace gases such as carbon dioxide, neon, and hydrogen. Notice the drop of carbon dioxide levels. It is due to the plants that were formed long ago, before the evolution of animals.
The history of our atmosphere is quite fascinating. Yeah, but what does the atmosphere brings to us? What are its functions? We will be answering those questions after some commercials.
Feeling weak? No energy? No motivation? Maybe need something straight from atmosphere. Introducing Chad's Energy Drink.
Welcome back to the BSEE Science Channel. Atmosphere is essential to us because of the air we breathe. What do you think are the functions of the atmosphere?
We breathe. The air we breathe is the product of the evolution of our atmosphere, as we seen earlier. Did you know? Earth is moving in space at an astonishing 67,000 miles per hour, which is roughly about 30 kilometers per second. As it moves, powerful UV radiation from the sun can harm us. What protects us from these rays? Atmosphere. As it turns out, atmosphere traps gases and heat, making it a natural blanket. It doesn't let any gases escape from Earth, which is also the other term for greenhouse. Extreme temperatures is inhabitable, isn't it? Extreme hotness in the morning and extreme coldness at night will not make any life forms alive. Atmosphere regulates sharp temperature changes. Weather formations are also done by our atmosphere. Atmosphere is our protector. It burns out space debris that enters our atmosphere. If we don't have protecting atmosphere, we will have craters like moon.
Our atmosphere is special and it protects us from the dangers of space. But can we also protect our atmosphere from the dangers brought by us? That will be all for today. Thank you very much.